All right, I think we're recording. Hello, everyone, and welcome to the first video lecture. A little warning before we jump in. The department has actually purchased me an iPad and Apple Pen, or purchased that I will then give back when I'm done instructing this remote course. But it is still on its way, so we are going to be working with a 5-year-old iPad today. So please excuse the fact that it'll be a little cumbersome, and I'm going to use this zoom in feature since otherwise you wouldn't be able to understand my handwriting. So on the first lecture, we were talking about the statistical process, and we did an overview of these first two steps of it. The first, identify a question or problem, and we used the example of this stents data set, and we wanted to know whether or not surgically implanting a stent would reduce the chance of somebody getting a stroke. After stating our question, we collected relevant data on the process. We had a treatment group that got stents, and we watched them for a full year. We're going to be looking at the year's worth of data here. And then we had a group that was the control group that we also followed for a full year and did not give them stents. So the third step of our statistical process is analyze the data. And we are going to start with a definition. A summary statistic is a single number summarizing a large amount of data. So we're going to start in trying to unpack what this means. We're going to use two examples. The first, the proportion who had a stroke in the treatment group. So looking at our data, the treatment group is this first row right here. And it would appear that 45 of them had a stroke out of whatever the total is. I think it is 224, which is equal to 0.2, or 20%. So look at what we've done here. We followed these people for a whole year. We applied a treatment to part of them. We didn't apply a treatment to another part, but we still followed them for the full year. We've collected all of this data, and we've taken it and we've boiled it down to a single number. And this single number represents a quality of the data. In this case, it tells us of the people in the treatment group, what proportion of them got a stroke of the total amount in the group. So that's the idea of a summary statistic. You take the whole data, you boil it down to a single number, and that single number tells you something about the data. Let's look at another example. This time, the proportion who had a stroke in the control group. In this case, we're looking at the second row here. And it would appear 28 people of a total of 227, which is 0.12 or 12%. So here again, we've boiled our data down to a single number. It would appear that of the people in the control group, only 12% of them who didn't get stents had a stroke after a year. So what we want to do at this point is take a step back and just look at the summary statistics that we've created. You'll note that what we have observed here is actually counter to what the doctors expected when they proposed this treatment. The proportion of people who got a stroke and got stents, who had a stroke after a year and got stents, that proportion is actually higher than the proportion of people who didn't get a stent at all and just waited a year. So looking at this data, it might actually appear that stents aren't really doing what they're supposed to be doing, which is preventing strokes. But let's be very careful to not say something inappropriate, to not make conclusions that we can't necessarily make yet. See, that's part of the point of this course, actually. And let's talk about the fourth part of the statistical process, form a conclusion. So based on what we've observed, can we conclude that stents increase the rate of strokes? Is there a real difference between the rate of strokes of these two groups? Now, that's a little nuanced. Is there a real difference versus did we observe a difference? We certainly did. We observed a difference in our sample. That doesn't necessarily mean that the specific treatment for everyone is going to increase strokes. Let me give you an example to that nuance a little bit. Suppose you flipped a fair coin 100 times. So it's a 50-50 shot every single time, and you do it 100 times. We wouldn't actually expect to get exactly 50 heads. We'd likely get something around 50, but it would be completely reasonable for us to instead observe 58 heads or 41 heads. And if we were to take a sample like that, flip 100 coins, see 58, would we assume that there's a 58% chance of getting heads? Or would we just say that there's some random variation that accounted for that discrepancy? So the natural question is this 8% difference, that's the 8% between the 20% of people who got a stroke in the treatment group versus the 12% of people who got a stroke in the control group, is this 8% difference real or just due to random chance? Is it, and I'm going to use a bit of a terminology here, is it conclusive? Is it such a significant difference that we can say, yeah, stents aren't a good thing? Well, this particular stent for this particular group of people isn't a good thing to do. And if 8% isn't conclusive, would 20%? If there was a 20% difference between the groups, would we be able to say something? What about 40%? At what point is the difference between the rates so significant that we would say it can't really be due to random chance? There's something going on here. We don't actually yet have the tools to answer that question. In fact, that's one of the purposes of this course, is taking a sample and knowing and having the statistical tools to say exactly when things are just so unlikely that maybe there's something up. Yeah, so that's about all I want to say about form a conclusion for the time being. It's certainly something that we're going to spend a lot of time on in this class. I would like to end with a warning to all of you, to you budding statisticians. And that is to be very careful not to make conclusions outside of the scope of your study. So if we made a conclusion from this data, which we will learn in what ways we can in the future, We have to be careful not to say anything about all stents for all patients. This study was a very specific type of stent for a very specific type of stroke patient. Patients who, by the way, volunteered and may not actually represent every single person who has a potential for a stroke. We can make conclusions about a very specific group of people for a very specific type of stent treatment. And you should really think about that whenever you're working with data, is exactly what you're able to say. And we are certainly going to practice that throughout the semester. So this was a short video lecture. Since it is the very first one, I'm actually just kind of practicing video lectures right now. Please take a look at homework 0. That will be our 0th homework. It doesn't really require a lot of thinking. It's more bookkeeping stuff, seeing if you're good at WebAssign, and I think I slipped something kind of fun in there. So I'm looking forward to see how you all respond to it. Yeah, so I look forward to seeing you all tomorrow for our second lecture.